All right, so today we're going to be factoring again, but looking at some more complex problems and using some of the shortcuts that we didn't get to yesterday. So briefly, I'm just going to recopy down those shortcuts from yesterday. You know, the difference of two squares is a minus b times a plus b. Then we have the perfect square trinomial. And then we have the sum of cubes. And then we have the difference of cubes. Oops, this one should be plus. So those are the formulas, and then grouping. We did that yesterday, and the difference between a plus b cubed and a cubed plus b cubed. So let's get into our examples. Got 8 of them here today. So we have x to the fourth minus 256. So this is a difference of two squares because x squared is x to the fourth, and 16 squared is 256. So we can factor that to x squared minus 16 and x squared plus 16. But now we can factor x squared minus 16 into x minus 4 and x plus 4. So this is our completely factored form. Now, number 2 over here, you look at that and say, well, let's get our parentheses out, and the way we can multiply and get 4x squared is 2x and 2x, or 1x and 4x. And then the last two numbers have to multiply to 9, so that could be 1 and 9, 9 and 1. But what I want to draw your attention to is when I recognize that this is a perfect square and this is a perfect square, I look up here to see if it follows the perfect square trinomial shortcut. So if this would be 2x, that would be our a in the formula, and this would be 3 in our formula. And if this were to work out, 2 times 2x times 3, we do get 12x, which is what we have here. So this is a perfect square trinomial, and because it's minus, it's going to be 2x minus 3 squared as your factored form. Now this one may have been easy enough where if you would have solved it by guessing and checking, you probably wouldn't have spent much more time, if any more time, than I did here. But as we get to more complicated ones, I want you to be on the lookout for the perfect square trinomial shortcuts, where the first term is a perfect square and the last term is a perfect square. You can use that, check to see if that formula works. All right, so number 3 is a little bit tricky. The first thing I'm going to do is I'm going to rewrite this in the order that we're used to. And now when we guess and check this, the nice thing is that because we have positive and positive, both of these have to be positive as well. So now I'm going to guess and check and use factors of 6 for the first. So I'm going to do 2x and 3x. And then the last ones need to be factors of 36. And there's a lot of them, and I tend to like to start in the middle or near the middle when I do guessing and checking. And I know we need to get 35. So I'm going to do 12 and 3 and see what gets us that. See what we get there. So when I do this, I get 36x, which I already know is going to be too big because I'm going to be adding something else. So it's just going to get larger. So I'm going to go to 9 and 4. Okay, see what this gets us. 9 and 3x is 27. Okay, that's okay. 2 and 4 gives us 8. So it's 27 plus 8x. That does give us 35x. So this is going to be our factored form, 2x plus 9 and 3x plus 4. All right, number 4 here, this is a sum of cubes where this is our a value, which is x, and then our b value is going to be the cube root of 27, or 3. So now I'm going to use that formula from up above for the sum of cubes. So it's a plus b times a squared minus a times b plus b squared. So there's not a lot of work really to show for this, but it just is something you have to remember. 3 squared is 9, so there we go. Number 5, I notice I can factor out a GCF. I'm going to factor out a 2, and we're left with 64x to the third minus 1. This is a difference of cubes because our a is going to be, the cube root of 64 is 4. So our h is going to be 4x, and our b is going to be 1. So when we write our factored form, we have to worry about that 2 that we factored out. So 2, and then it's going to be a minus b times a squared. Now I have to do a squared, which includes the 4, so it's 16x squared, and then plus a times b, 4x, plus b squared, which is 1. So that is our factored form, after we account for that GCF. All right, so number 6, we have 3x, and then in parentheses, x minus 4, then minus 5x minus 4. And you might be like, oh, let's just distribute everything, combine everything, and then go ahead and factor it. But what I want to point out is that we have this thing right here minus this other thing right here, and those two things have a x minus 4 binomial being multiplied to each of them. So we can actually factor out that x minus 4, and then what we're left with is 3x minus 5. So it's kind of like factoring by grouping. If we go back to what we did yesterday, it's kind of like factoring by grouping with this step right here where we had two things being added, and we said, oh, they have these two in common, let's factor that out, and then we have our leftovers. Now, if you would have multiplied it out and factored it then, you still would have gotten the same answer, but this was significantly quicker. We're going to use that idea in number 7, because we have 7 times 3x minus 1 squared plus 4 times 3x minus 1 times 7 minus 2x. So both of these things have a 3x minus 1 factor. The first term, the one I underlined in blue, actually has 2 of them. So we're going to factor out a 3x minus 1. And then what we're left with in the light blue is going to be 7 times 3x minus 1. Oops, parenthesis there. Because there were 2 of them and we factored out 1. And then in green, we have 4. We factored out the 7x, or sorry, the 3x minus 1, so it's going to be 7 minus 2x now. Now I look at the insides here and say, can I do anything there before simplifying? Nope, there's nothing else to factor, so I'm going to distribute, and then simplify this. So we still have this 3x minus 1 hanging out, and then we have to distribute, that gives us 21x minus 7 plus, when we distribute the 4, 28 minus 8x. And then we can combine like terms in the second parenthesis. 3x minus 1, and then 21x minus 8x is 13x. Negative 7 plus 8 is 21. So this is our completely factored form. Now, if you would have multiplied all that out, it would have, and factored it, you would have gotten this, but again, this was probably a little bit quicker than doing all of that. And then lastly, number 8. Well, there's already 4 terms, so I'm going to check if I can do factor by grouping. All right, if I look at the first two, they both have an x squared because this one's x to the third times y, and this one is 4x squared y. So we can factor out an x squared and a y, and then we're going to be left with x to the first power minus 4. And again, if you're ever unsure, just distribute this back in to see if you get what you started with. The second two terms, or last two terms, are going to factor out a negative 4. That's going to leave us with x minus 4. And yep, these two are the same. So we can do the factoring by grouping technique, and we're going to get x minus 4 times x squared y minus 4. And technically what we did in this step right here is we factored out, we saw that they both had an x minus 4 in common and factored that out. Right. So that's it for our factoring lesson. Now we've got a review of all the types of factoring we'll see. So hopefully we can extend this later on in the year. Thanks for watching. Make sure to smash that like button and subscribe.